Hello everyone. This video would focus on conic section, specifically on ellipse with center at 0, 0 or at the point of origin. And this is the third part. In this part, we are supposed to determine the standard equation of an ellipse given the coordinates of the two vertices and the coordinates of the two foci. Before we go over this example, let's have a review on the parts of an ellipse and the two cases of an ellipse with center at 0, 0 or at the point of origin. We remember that there are two cases of an ellipse. The first case here is the horizontal ellipse. Before we go over this case, let's have the parts of every ellipse. The first part that we have here is the center. The center is halfway between the two diameters of the ellipse. The second part that we have here is the major axis. The major axis is the longer diameter of an ellipse that connects the two vertices passing through the center. So this means that both of these two dots that we have at the end of the major axis are the vertices. So one is the vertex and the other is the other vertex. The plural for that is vertices. So pretty much vertex is the end point of the major axis. Now we also have another diameter which we call as the minor axis. This is the shorter diameter of an ellipse that connects the two co-vertices of an ellipse passing through the center. So this point right here is a co-vertex of an ellipse, and this point down here is also a co-vertex of an ellipse. The next part of an ellipse is focus. So these 2 points right here are the focus of the ellipse. The plural for focus is foci. This focus is always gonna lie along the major axis. Please remember that foci of an ellipse are two fixed points on its major axis such that the sum of the distance of any point on the ellipse from those 2 points is constant. So those are the basic parts of an ellipse. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis. So that means this runs from the center to the vertex, and we are going to represent this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, meaning this connects the center to one of the co-vertices. And this line segment from the center to the co-vertex is represented as letter B. Now, on the other hand, from the center to the focus is represented as letter C. Now, using these letters A and B, we can derive the equation of a horizontal ellipse. Now, using these lengths A and B, we can come up with an equation of a horizontal ellipse, and that is x squared over a squared plus y squared over b squared is equal to 1. Now, notice that our A is the longer value, because this is actually half of the major axis, which is the longer diameter. Now, notice that our A, which is the longer value, is the denominator of x squared. This means that if the denominator of x squared is bigger compared to that of the denominator of y squared, that means that we can come up with a horizontal ellipse. Now, we also remember that our A value, which is the semi-major axis, will always be greater than B, which is the semi-minor axis. That's always every time. And the equation that can be used to determine the length of C, that is from the center to the focus, is C squared equals A squared minus B squared. Now, let's look at the second case of an ellipse. For the second case of an ellipse, we pretty much have the same parts. The first part is the center. Again, this is halfway between the two diameters of an ellipse. We also have a major axis. This is the longer diameter of an ellipse that connects the two vertices passing through the center. Now, please notice that we call this as a vertical ellipse because the major axis is the vertical line segment. We also have the parts which we call as the vertex. There are two of them. We call them as the two vertices. These are the two endpoints of the major axis. We also have a minor axis that is the shorter diameter of an ellipse that passes through the center and that connects the two co-vertices. And again, on this, along this minor axis, we have the co-vertices or the co-vertex if it's singular. These are the endpoints of the minor axis. Now we also have another part which we call as focus. So these 2 points right here are our foci. So pretty much these are the parts of an ellipse. So it doesn't really matter if it's a vertical ellipse or a horizontal ellipse. The parts would still be the same. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis, which means this connects the center to the vertex, and we are going to label this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, which means this connects the center to the co-vertex or one of the co-vertices. And we're going to label this as our B. Now, we also remember that the distance from the center to the focus is represented as letter C. Now, using these lengths A and B, we can therefore say that our equation for a vertical ellipse is x squared over b squared plus y squared over a squared is equal to 1. Now, notice that our a squared is under the y squared. This means that if the value under or if the denominator under the y squared is bigger than the denominator under the x squared, we are able to get a vertical ellipse. And we also remember that again, our A is always greater than B. Now to determine the length of C, we are going to use the equation C squared equals A squared minus B squared. So these are the parts of an ellipse, and these are the two cases of an ellipse. Now let's go back to the problem. Okay, going back to the problem right here, we are supposed to determine the standard equation of an ellipse with these two vertices right here. So it's at 0, 8 and 0, negative 8. So I'm gonna go ahead and plot these two vertices here. So 0, positive 8. And then that's the first vertex, and then the other vertex is 0, negative 8. So this is another vertex here. Now we remember that the center of an ellipse is the midpoint between the two vertices, or the midpoint between the two co-vertices. So in this problem that we have right here, we're supposed to determine the midpoint of these two. We can use the midpoint formula, or we can just go ahead and trace it where it's located at. So in this case right here, we go down 1 all the way to the middle, and we can see that our center is the point of origin, or at 0, 0. So I'm gonna go ahead and label this as the center. And so we can go ahead and say that this ellipse is a vertical ellipse because the two vertices are on the vertical line or on the y-axis. So I'm going to go ahead and write that up here. Okay, so then we are going to plot these two foci right here. So we say that it's at 0, square root of 39, and 0, negative square root of 39. So we remember that square root of 39, if we use a calculator on that, that is approximately 6.24. So we can go ahead and say that this is 0 and 6.24, and this is also 0 and negative 6.24. So we can go ahead and plot this two foci right here. Okay, our task is to determine the standard equation of this ellipse. Now we are going to write the general equation of this vertical ellipse down here. Okay, since this is an example of a vertical ellipse, so I wrote this equation right here for vertical ellipse. Again, notice that our a squared is under the y squared since we have a vertical ellipse. So looking at this equation, we're supposed to determine the a and the b, but we're given these two values right here. Now we remember that this foci right here is represented as letter C, which is equal to the distance from the center to the focus, or from the center to the other focus. In this case right here, it is equal to square root of 39. So that is square root of 39 right here, approximately 6.24. So I'm going to write here square root of 39. That's the C value, but then we don't really need the C to determine the equation for this. We need an A and a B. Now we remember that vertices is represented, or the location of the vertex is represented as letter A. That is the distance from the center to the vertex. And again, that is represented as letter A. So in this case right here, we have from the center to the vertex, if we count it, 1, 2, 3, 4, 5, 6, 7, 8. So it is 8. We can use the distance formula to determine the value for the distance between the center and the vertex. We can do that, or we can just go ahead and count it. That is still the same. So we can go ahead and say that this A can also be written as A squared is equal to 64. So we already have a value for A squared, so that we can go ahead and rewrite this equation as. So the next missing piece that we have here is letter B. Now we remember that for every ellipse, we can use the equation C squared equals A squared minus B squared. So I'm going to go ahead and write that up here. So then from here, we can go ahead and solve for B. Now looking at this, we have a C of square root of 39. So I will plug that in here. And we have an A squared, which is 64, so that we can solve for B. So this comes out square root of 39. And then again, that is squared equals our A squared is 64 minus B squared. So square root of 39 squared is just 39. So we can go ahead and cross out the square root and the squared. So we are left with 39 equals 64 minus B squared. So then we can go ahead and subtract 64 from both sides. So this minus 64 and minus 64. So then we are left with negative B squared equals 39 minus 64 is negative 25. So that we can go ahead and say that our B squared is actually 25, positive 25. So if we divide negative 1 to both sides, then it will come out positive 25. So this means that our B then here is equal to plus minus 5. So we already have a value for B squared, so we plug that in here. So this is 25. So this is the equation for this problem that we have up there. B value is plus minus 5. This represents the co-vertex. So that means we go 5 to the left and 5 to the right. So this is the first co-vertex and this is the other co-vertex. So we can go ahead and sketch the ellipse. So I'm going to go ahead and write the coordinate of the two co-vertices down here. So this is the equation of this problem up here, and this is the graph of this ellipse that we got right here. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're given the coordinates of the two vertices and the coordinate of the two foci. So we go ahead and sketch these two vertices and these two foci. So what I did here was I plotted the points for the two vertices and plotted the point for the two foci. Now we remember that the center of the ellipse is the midpoint between the two vertices or the two co-vertices. So I traced the middle between these two vertices and it's actually at the point of origin or 0, 0. The other option that you can have here is to use the midpoint formula to determine the location of the center, and it should be at 0, 0. So that from here, we can go ahead and say that our center is at 0, 0, and this is a horizontal ellipse because the two vertices and the two foci are located on the x-axis. So I'm going to go ahead and write that up here. Okay, since we say that this is an example of a horizontal ellipse, I am going to write the general formula for the horizontal ellipse down here. So this is the general equation of a horizontal ellipse. Now, again, notice that our a squared, which is the bigger value, is under the x squared, since, again, this is a horizontal ellipse. So in this case right here, we can go ahead and say that we need a squared and b squared so that we can get the equation for this ellipse. So we remember that the foci here is the location of the foci is represented as letter C. And so we can go ahead and say that our C value here is gonna be 4 square root of 2, or approximately that is 5.66. But we don't really directly need the C to determine the equation. We need A and B. Now, looking at the other coordinate that we have right here that says vertices. So we remember that the distance from the center to the vertex is represented as letter A. So in this case right here, our A then is equal to, if we count it, it's 9. The other way to do this is to determine the distance between the center and the vertex using the distance formula. We should be able to solve, or we should be able to get 9. So I'm going to go ahead and write 9 up here. This tells us that our a squared is 81. So that we plug that a squared in here so that we can write the equation of this ellipse. So that would be x squared over 81 plus y squared over equals 1. So we still don't know what the b is. But we remember that this A, B, and C measures of an ellipse can be worked together in an equation. C squared is equal to A squared minus B squared. So our C is 4 square root of 2. Our A squared was already 81, so we can solve B from there. So I'm going to show the work down here. Okay, so what I did here was I plugged in the value of C and then I squared it. The reason why I got 16 times 2 here, because 4 squared is 16, square root of 2 squared is 2. And so I got this value 49. So that I can go ahead and plug that value of B squared down here, which is 49. And this represents the equation of this problem that we have up there. So I'm going to put this inside the box. And so we can go ahead and sketch the graph of this ellipse. So we say that our B is plus minus 7. This represents the distance from the center to the co-vertex. So I go up 7 and down 7. So this is where the co-vertex is going to sit. So I will label that as co-vertex. And then the other co-vertex is going to be down here. And so we can go ahead and write the coordinate of the co-vertex down here. So this is the equation of this problem right here, and this is the graph of this ellipse. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!